Today on the Beam channel, I wanted to talk to you about what is property-based testing. This is one of my favorite topics in programming, and I'd like to say that if you'd like help getting started with it in your team, give me a shout. I do a training course. I can do it in either Erlang or Elixir and help you get started, because this is really awesome, but it does have a bit of a learning curve. You're all familiar with a unit test. And in a unit test, let's say you're testing the function, so it says you're testing the Elixir function list delete. Right, it's a standard library function. You shouldn't actually retest for it, it's fine. But hypothetically speaking, so you might write a few tests like this, where you test it on an empty list, you test it where the key is there, the key is not there, etc., etc. With property-based testing, you're not going to explicitly give it items to test. You're going to specify a general principle. And that principle is, in this case, we're going to say that if you create a list of integers, which we're going to call the haystack, and a specific integer, which we're going to call the needle, and you call list delete on that, the new list should not have the needle in it, right? Okay, fine. It should have deleted the elements that have that element. That's a good property to test. And if you run it, you will discover that eventually that fails. Well, it turns out if you read the documentation for list.delete, it only actually deletes the first instance of any element. So if there's more than one, it'll only delete one. The property we asserted turns out to be not true, but this is useful because it's illustrative. The instance that the version of it that it might have found could look something like this. Now, if you see that you've got a list. You're trying to remove the list number 100 minus 196 from that ginormous list. Now, if I said to you, if I showed that example to you and said, hey, it's not working, you would probably be like, I don't know, that's something. That would be hard to understand. So what it then does is it implements a concept of shrinking, which is to say, if that really long list of numbers has a fault in it, maybe a shorter list does too, and we'll remove one and see if it happens again. And if it does, we'll remove another one, and so on. This is, in fact, a very basic computer science thing. It's a depth-first search of a solution space. Eventually, we get to, in this case, when I ran it, this example, which is negative 45 from the list negative 45, negative 45. Now, if you ran it a bunch of times, you'd get a different result each time. You might get, positive 6, minus 2, 0, whatever. But you'll always get moving an item from a list that is just those two. So you can very easily see, oh, this is a duplication error. The fact that there's two items is what is significant. To tell a story of one thing I did with this once, back when Chicago Boss was still being developed, I was working on that, and I wrote a test where, it's either Postgres or the MySQL driver, I don't remember. I created a random string. I saved it to the database. I read it back, and I said, okay, that the string I got back should always be the string that I sent in, right? It's a good test you want. And, your database should do that. And it turns out there was an escaping error, and again, it found some ginormous string, and then it reduced it down to / / space. And then the backslash just disappeared. Well, again, you can say it's very simply, oh, it's an escaping error. I know how to solve that. By the way, if it's not obvious, run it a few more times, you'll get a few different examples, and it should let you sort of figure out what's significant. In this case, you might say, well, maybe it's the fact that it's a negative number is significant. All right, probably not, but in a more complex case, that could be a thing. So you'd run it again, and you'd get a positive number next time. Okay, that's not significant. So you can do that. This is a really effective way of finding all sorts of weird bugs, and this is only scratching the very surface of it. Now, if you're using Erlang or Elixir, there are 3 different libraries you can use it. Search for this QuickCheck, which is amazingly powerful. You can do all sorts of awesome things, but it's also commercial, closed source, and licenses are rather expensive. They have a mini version, which is free, although I'm not sure when it was last updated. There is PropCheck, which in Elixir, and Proper in Erlang, which is from Costas' team at Uppsala University. It is free under the GPL. That may or may not be a problem for you. Just consult your legal department. I think it's okay. And it has a lot of things, and it's got some really cool stuff being added to it in terms of directed testing using simulated annealing and stuff like that, which is subject for another video, or you can go look up their papers on the web. And then there is Trick, which is not being as heavily updated, but is under a more permissive open source license. Now, if you're using some language that is not Erlang or Elixir, which you might. There are also versions of this. In JavaScript, you have JS Verify. In Python, you have the very excellent Hypothesis library. In Elm Test does this. In other languages, you can find other things, the Scala, Clojure, etc. And it's just a question of looking. Make sure not all instances of this, especially those that support shrinking feature. That's very important. That is what actually makes this useful. This whole technique was originally started actually in Haskell, with QuickCheck in Haskell by John Hughes at Chalmers, and has evolved since then. I'm a big fan of QuickCheck. I've used it over the years to find, in various different instances, both the QuickCheck and the free versions, all sorts of interesting bugs in systems, and that I find that is a great way to do that. So, if you'd like help getting started with QuickCheck, using any of the versions, please give me a shout via the Calendly link below, and I would love to come and give your training course to your team, pretty much wherever you are in the world.